radical expressions. So many students struggle with simplifying radical expressions. Before we get into the problem set, I think I want to just help you conceptually understand why the method works that works. So let's just start off with an example. Let's say we had the square root of 4 and square root of 9. Now, when you see square roots right next to each other like that, that means they are being multiplied together. So this means the square root of 4 times the square root of 9. So we could ask ourselves, what is the square root of 4? Well, that's 2. What is the square root of 9? Well, that's 3. So 2 times 3 equals 6. Okay, if we were to set up the same problem, and rather than first taking the square root and then multiplying, what if we multiplied these two square roots together? 4 times 9, if we were to combine them and put them all under one roof, we would say, now it's the square root of 36. Well, what is the square root of 36? Equals 6, right? So we got the same answer, whether we take the square root first and then multiply, or whether we multiply and then take the square root. So essentially, what we can conclude from doing this is that we can break down these radicals into simpler parts, right? And let's go back. So we can now say that radical 36 is the same thing as or equals radical 4 times radical 9, right? We just proved that. Those two things are the same things. So 4 and 9 are special though, because these are both perfect squares. They both have perfect square roots. You could also, if you wanted to, take this square root 36 and separate it into square root 18 and square root 2, because 18 times 2 equals 36, so we're not breaking any rules. But the problem is here that 18 doesn't have a square root, a whole number square root, and 2 doesn't have a whole number square root. They're not perfect squares. So though you can separate 36 out into 18 and 2, and it's not technically wrong or inaccurate, it's just not helping you get any closer to a simplified version. But when we do take 36 and we separate it into perfect squares, once we do so, because both 4 and 9 are perfect squares, we have answers to those. We know the square root of 4 is 2, and we know the square root of 9 is 3. So our final simplified answer would be 6. So let's get after some of these problems here. I think a good place to start with these problems is, on the side of your paper or on the top somewhere where you can have access to it, is create yourself a little menu, like 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. If you're taking a test or studying for a test, I recommend, writing this on the top of your test when you go to take it, because it can really help. So when we address a problem like number 1, and we think of it with the example that we did breaking down 36 into our 4 and 9, we now have 125, and we need to just ask ourselves where, looking over at our menu here, what perfect squares can go into 125? Well, the first thing that jumps out to me is this 5 squared is 25. And I know that 25 goes into 125. So we can separate this out here, and we can say, let's call it the square root of 25 times the square root of 5, right? Because 25 multiplied by 5 is 125. So we separated that 125 out into two squares, just like we did the 36. We separated it out into square root 4 and square root 9, because 9 times 4 equals 36. We separated this out into square root 25 and square root 5, because when you multiply these two, it equals 125. And we also can, for now, we'll just put this square root n to the side. So we have the square root of 25 multiplied by the square root of 5 multiplied by n. And once you do this, you need to ask yourself, why did we do this? Why did we separate this out? And specifically, why did we choose to separate it in this way with these numbers? Well, it's because 25 is a perfect square. We know the square root of 25 is 5. 5 times 5 is 25. But these two, when you look at them, you have to ask yourself, if we go back over to our menu here, are any of these numbers, can they go into 5? None of them can. So that's when we know, when none of these numbers in your menu, 4, 9, 16, 25, when none of them can go into the number inside of your square root, that's when you know it's as simplified as possible. We don't know what n is. It's a variable, so we don't know if it's a perfect square or not. So we just have to leave everything that can't be simplified together inside the house. So we're smushing these two together back under the house. So this is the most simplified version. Now let's look at 216. Already the temperature is heating up. 216. Okay, so some of you who are good at mental math might already be able to say, all right, does 4 go into there? Does 9 go in there? 16, 25, 36. Which one of these goes into 216? And you might come up with one that is true and different than somebody else. And I'll show you how ultimately it leads to the same path. So I'll give you a second to think about it. I know that we can divide 216, and I recommend just using your calculator. 216 divided by, starting at the highest on the list. If you put into your calculator 216 divided by 36, you get 6. So we can separate this out into square root 36, and it's 36 times 6, which equals 216. And we're going to keep our separate square root v. Okay, so some of you may have found that 9 goes into 216, and that can work as well. But you always have to ask yourself the question, as you feel like you have your final answer, can there be any more simplification? I'll bring this house over a little further. So why did we choose to separate it out into 36 and 6? There's a lot of different numbers we could separate it out into, but we chose this because we actually know what the square root of 36 is. That's why we chose to separate it out into 36 and 6. The square root of 36 is 6. Now we have our square root 6 and our square root v left. We can go back over to our menu and ask ourselves, can 4 or 9 or 16 and so on, can it go into 6? And if the answer is no, then we are in the simplest form. So this would be, on the outside of the house, you have your 6, and then on the inside of your house, it's everything else that remains that can't be taken out of the house, or you cannot find something to simplify it down to. Let's do another one. 512k to the square. So now not just a k, but a k squared. So some of you with great mental math skills might be able to, go over and look at your menu and say, hey, which one of these numbers, and I recommend starting higher, uh, will will help us, right? Does a 36 go into 512? You can put 512 into your calculator, divided by 36 to find out, and you'll find it's not a clean number. It's 14.2 repeating. I already know that 25 doesn't go in there. What about 512 divided by 16? We get a 32. So there may even be a more efficient path than that, but I'll show you how this can work even if you don't take the most efficient path. So I just came to find out that 36 does go, oh, I'm sorry, 16 is what I meant to say. 16 does go into 512. How many times does 16 go into 512? Goes in 32 times. So 16 times 32 is 512. And we also have this k squared. So why did we choose to divide it into 16? Well, 16 came off our menu, right? Because we know the square root of 16. There's a ton of different things we could have separated 512 into, but we want to strategically choose ones that have squares so we can pull things out of the house. The goal is always to pull things out of the house until you cannot pull anything out anymore. So now we have a 4 on the outside, but we have to ask ourselves, this 32, can it be separated into anything? I notice that half of 32 is our 16, right? So we know for sure that we could separate radical 32 out into radical 16, radical 2, and we still have our radical k squared. So we'll continue just bringing I'll create some room over here. And we'll say we have our 4 on the outside. And now what is the square root of radical 16? Well, the square root of 16 is 4. So anything that's on the outside gets pulled out of the house, right? This 16 turned into our 4 here. And this 16, the next one here, turns into our second 4. But now we still have a radical 2. Nothing in our menu is going to go into that radical 2, so it's going to have to stay in the house. But what is the square root of k squared, right? If we take a little side quest here, we know that k squared equals k times k. All right, and remember, if 4 times 4 is 16, therefore the square root of 16 is 4, then the square root of k squared simply equals k, because k times k is k squared. So we're left with this other k that no longer has a house because the square root of k squared is k. So now that we've taken everything out of the house that we can, and what remains in the house is going to remain, we take everything that's outside of the house and we multiply it together. So starting with what is 4 times 4? 16. And we have this k here that will have to remain outside the house. And then this radical 2 cannot come out of the house because it cannot be further simplified. Let's do one more. Let's move down here to this number 7. 80. So we're asking ourselves that number 80. Does 4 go into it? Does 9 go into it? Does 16 go into it? The higher, the better. Sometimes I just like to go with what I instantly notice. I noticed 4. I know for sure 4 goes into 80. So I can call it radical 4, radical 20. Now I'm going to strategically set this p cubed into two radicals. I'm going to call it p squared and p, right? Knowing that if we multiplied those together, we'd have radical p cubed. So I just separated them out into two parts. P squared times p is p cubed. So let's harvest the fruits of our labor here. We know the square root of 4 is 2. Now this 20, I get the sense that we can separate this out because I know that 4 goes into 20. So I'll separate this out into radical 4, radical 5. So when you have to simplify again in a second step, it means you just took not necessarily the most efficient path to get a solution, but you'll still get the same solution. So what is the square root of p squared? Well, p times p is p squared. So the square root of p squared is p. We don't know what p is, so we don't know if it's a perfect square. We have to leave it in the house. Okay, so once again, let's sort of simplify down and take advantage of the work we done. Let's bring our 2 straight down. Now this radical 4, the reason we separated that 20 into radical 4, radical 5 is because we know the square root of 4. It's 2. 5 will not be able to be simplified. We're going to have to leave it in the house. We already took 1p out of our house, and we have 1p remaining in the house. So everything that can come out of the houses is out. And now our last and final step is to simply multiply everything that's outside of the house and put it in front. So 2 times 2 is 4. We can't forget our p that we have here. Now we also have in the house, we have our 5 from above and a p, right? We have our 5 and our p. So our final answer will be 4p radical 5p. I hope you are feeling more confident with simplifying radicals.